Hello friends, in the current video tutorial I am going to talk about using multiple scales on waveform graph to plot diverse datasets in LabVIEW. So let's get started. So before going on to displaying multiple scales on waveform graph, I would like to first talk about when to use multiple scales. So when we are plotting data from diverse datasets, right? Using multiple scales on a graph when you need to display and compare data with vastly different units, vastly different magnitude ranges, different data sets. So then we use multiple scales. This technique is often called dual axis or multi-axis graphing. It is useful for seeing the relative trends of different data sets over time or over different ranges of diverse data sets having different measurements units or different magnitude ranges. It is particularly helpful when a single axis would make one of the data series appear flat or difficult to read due to extreme difference in the scale. Means when the ranges in the data to be displayed are very different in different data sets. One range is too big and the other range is too small, so the smaller range data appears cramped. So when we use single scale, this cramping will affect the visualization of the data. So in that case particularly we have to use multiple scales to avoid cramping of the lower range data. So now I will show you this on the software and will show you how this cramping happens and how we use multiple scales to avoid this cramping. So now we are going to see on the software how multiple scales are used to plot data from different data sets simultaneously on the same graph. So this is the waveform graph in which I am using multiple sets of data to be plotted using multiple scales. So I'm plotting data between degree Celsius with respect to Fahrenheit scale, then degree Kelvin scale and degree Rankine scale. So I've used the formulas for Fahrenheit, Kelvin and Rankine. I'm getting 3 arrays and then I have combined together all the arrays to form a build array. Use the build array to form the combined array for all the 3 arrays. So this is a concatenated array, and then I have appended array. This is an appended array, and then this is combined together in the bundle function to create a cluster, and that is plotted onto the waveform graph. So now when I plot this data, I will have different scales. So when I run this, I have a data for degrees Fahrenheit with respect to degree Celsius, degree Kelvin with respect to degree Celsius and degree Rankine with respect to degree Celsius. I have a visualization that how the data of Fahrenheit changes with degree Celsius and simultaneously degree Kelvin changes with degree Celsius and degree Rankine changes with degree Celsius. On the axis y-axis 1 I have degree Fahrenheit, which is displayed in creamish yellowish color. So this is the first data in degree Fahrenheit, then degree Kelvin in red, which is the scale number y-axis 2 scale, and then degree Rankine in green. So that is scale number 3, y-axis 3 is this. So degree Fahrenheit, degree Kelvin and degree Rankine. On the x-axis I have degree Celsius. So I should mark it that it is x-axis. X-axis degree Celsius. So I have used these multiple scales. Now firstly, how to use multiple scales, how to put data on the multiple scales. So you have to click over this portion, means somewhere over here or here, and then you have to say duplicate scale. So when you duplicate scale, another scale will appear, right? And similarly you can delete the extra scale, delete scale, so the extra scale will disappear. Of course you have to set the ranges of these scales as well. I will show you later on. Now there is a possibility of swapping the sides also. So if you select over here swap sides, so it will go on the other side. Now degree 2 degree Kelvin y-axis 2 scale is now on the right, earlier it was on the left. Now I can swap it back, clicking swap sides. Now it's back here. So y-axis 2 and y-axis 1 degree Fahrenheit, y-axis 2 degree Kelvin, and y-axis 3 degree Rankine. So this is the way how you can use multiple scales. You can put as many scales as you want, and similarly on the x-axis you can have multiple scales. Click on over here and then duplicate scale, you will have another scale, so you can put some other units. You can set the ranges and whatever you want to do with the scale you can do it. So I delete this scale, x-axis 2 scale, I don't need it, so I delete it. Now let's see how to set the ranges. So you go on to the properties and then you have to select X scale, range, auto scale disabled, and then y-axis 1 auto scale disabled. Range you can set over here, you can set the multiplier and other things, scaling factors also. Then y-axis 2 again you can set the ranges, and y-axis 3 you can set the ranges. So if you can see, the ranges of Celsius is from 0 to 100 degree, ranges of Fahrenheit is roughly 30 to 240, and the ranges of degree Kelvin is 250 to 500, because 0 degree is 273.15 degree Kelvin. So 0 degree and 273.15 is the freezing point of ice. So this is kept in mind while setting this range. Similarly you have the degree Rankine range, so you can set it, and then you have to select the plots also. For every plot you have to select which axis is for which plot. Supposingly I am taking degree Fahrenheit, so I have to set that y-axis 1 is degrees Fahrenheit, right, from here drop down menu. Similarly Fahrenheit degree Kelvin, you have to select that it is degree Kelvin y scale, and on degree Rankine you have to select that this is degree Rankine. Similarly you can select the x-axis scales also with respect to the y-axis scale. So if you can see, 0 degree 32 degree Fahrenheit is 0 degree centigrade, then 273.15 degree Kelvin is 0 degree centigrade, and 491.67 degree Rankine is 0 degree centigrade. I will show you another example where I will show you the effect of cramping when different ranges of data is being used. So now in this another example, I am plotting cubes with respect to sample data x-axis, and I'm plotting squares on the same graph with respect to same x-axis sample data. So I'm taking the values from -50 to +50, and I'm plotting the squares and cubes of those on this waveform graph. So this is the waveform graph. Let's now see it properly. So as I plot it, I have two scales, y-axis 1 ranging from 0 to 2500 and y-axis 2 ranging from minus 15,000 to plus 15,000. So widely diverse data sets. See the range 0 to 2500 and then other range minus 15,000 to plus 15,000. So very different. Now see, the data is displayed very properly. There is no cramping and cubes are plotted in red and squares are plotted in green. So this is only because I have used multiple scales. So let's see, if I remove the multiple scales, what happens. You will clearly see the cramping of the data. Suppose I delete this scale, delete scale. See, now the squares data is cramped. It's just a straight line. I cannot see anything. The cubes data is plotted quite good enough, quite well. It is not a problem, but squares data is cramped. So I have to add another scale. So if I add another scale like this in squares, the data does not get cramped. So this is the main advantage. This is for data comparison, data visualization from diverse data sets having different ranges and avoid cramping. So this is the use of multiple Y scales. And similarly, if you have multiple X scales, you can use multiple X scales also, such as y-axis 1 with respect to x-axis 1 and y-axis 2 with respect to x-axis 2. So that comes to the end of the video. I hope you have understood the concepts properly and you have liked this video. Thanks for watching this video and come again.